Hello, my name is Divya and I'm here along with my teammates to present our final year project, multi-factor-based nutrition management system and recipe recommendation system. We were a team of 4. Team details are as shown on the slide, and our project guide was Dr. Shilpa Shashikant Chaudhary. Nutrition management in the context of this project aims to quantize the consumption of essential nutrients in an efficient format such that it leads to a healthy and balanced lifestyle. Several recent studies have shown the importance of quality-based consumption of nutrients, which could otherwise lead to serious health issues that could be fatal at times. Increased consciousness towards one's health has recently been in limelight, which creates a need for intelligent systems, especially based that would act as proof of concept for the solution, build an application to showcase the effectiveness of solution provided, and then test it in real time with real-time users. Now I will explain the approach that we use to reach the solution. At first, the user sees a UI application which will take in the basic information from them like age, gender, or the nutrition profile and deficiencies. This information will be passed on to a functional component which will analyze the user's nutrition profile, compare them to the standard values of nutrition at that particular age and gender, and create a data set of the ingredient or of the nutrients that the user needs to consume more of and in what quantity. Now, these nutrition values are mapped to ingredients using a k-means clustering algorithm. These ingredients, then we use these ingredients and then incorporate user preferences. These could be preferences like their likes or dislikes or the ingredients available to them in their home. These user preferences are then passed on to an API called the Spoonacular API to get food products. We fetch the food products and fetch the nutrition values in those food products. And then we rank the food products based on the user's nutrition values. The ranking would be in such a way that the food product that will satisfy most required nutrition values would be at the top of the list. Now, after we get the final food products, we scrape the internet for their recipes. And then these recipe videos are shown to the user on the.
Moving on to the datasets analysis and description. We've used 2 datasets in this project, both of which were obtained from NIN India, or the National Institute of Nutrition, India. The first dataset includes the standard set of nutritional values that the user must possess, given the age and gender of the user, while the second dataset consists multiple nutritional values of around 335 unique commonly used ingredients. In order to clean the data, we have deleted redundant data and averaged out similar data. Moving on to the next slides, we come to the experimental results. Here you can see that what we've done is essentially break down the 300 ingredients into 30 clusters with 10 ingredients in each cluster. But this cannot be visually exhibited in a 2D graph since there's no linearly separable hyperplane that can segregate the clusters. Moving on to the next slide, we come to the experimental results, simulations, and observations. You can see that for a person who is deficient in carbohydrates and protein, the recommendation engine suggests more protein and carbohydrate for consumption, while for a user that has shown excessive level of saturated fat, you can see that the engine recommends lesser fat in his or her diet. Moving on to the next slide, you can conclude that the solution was provided, which revolves around the idea of identifying deficiencies, building clusters to identify the required ingredients, and assembling food products and ranking them according to the user's nutritional profile. An application was built to verify the solution in real time, and this project will be led over to TDU, and they will be able to build up on this existing solution. We faced a couple of challenges. One of them was finding reliable REST endpoints, while the other one was to find efficient parameters for web scraping in order to get relevant outputs. Moving on to the deliverables, you can see that we have a novel-based solution that tackles the problem statement, and we also have a code base to implement the base idea to verify the sanity of the set solution. We also have a beautiful, elegant UI that provides a very good user experience and makes it very easy for regular users to use the application. It's also been tested in real time, and the handing over to TDU for the solution to be adapted will take place as soon as this project is approved. This project has also been reported to the Science of Computer Programming Journal to be posted as a publication.
Hello all, I'll be talking you through the implementation of the backend server and the available endpoints. The main list of endpoints the user would use are the functional endpoints. The important one is the personalized recipes that would take in the user's nutritional consumption data and send back recipes that are based on the user's nutritional requirements. There are also endpoints that particularly focus on individual macronutrients if the user wishes to consume them. There are ingredient APIs that show a list of ingredients, both veg, non-veg, and all of them that are used to take in users' particular preferences when users trying to consume them. And now coming to the actual implementation of the backend server itself, which is a Flask server. The most important endpoint the user would use is the personalized recipes. Here we're trying to take in the men, women data for each age range. That is the primary data set along with the ingredient data set. The first thing is to find the user's nutritional requirement. We do this by finding the arithmetic difference between the user's nutritional consumption and the standard consumption rate. This gives us user's deficiency or the nutrients they overshoot in. We invert them and add them to the user's the required nutritional values, so we get the user's required nutrition consumption for that particular meal. The next important function is the getting the ingredients function. Here we're trying to normalize our data and then add the user's nutritional requirement as an ingredient into the ingredient data set itself. So we could put all of them in a clustering algorithm and get similar ingredients similar to the user's nutritional requirement. We do this by running the k-means cluster and a set defined number of clusters. Because k-means cluster is a non-deterministic algorithm, it does not always guarantee a certain number of clusters or clusters with the same number of ingredients. So we reshape the clusters in such a way that they always return the 9 closest ingredients to the user's nutritional requirement. The next functional component is to get the food products. We do this by contacting Spoonacular via their APIs. They provide a bunch. There are multiple implementations for this function. One is the one for getting the ingredients. Recipes based on the user's suggested ingredients. There are also functions to get food products for particular macronutrients like proteins, carbs, and calories. We then pass the API response and then we rank the food products based on the user's nutritional requirement. This is done by scraping the web for the nutritional values of each of the food products and then ranking them based on the user's nutritional requirement. And this is done by using Euclidean norm. Then each of these video titles are sent as query to YouTube, and we retrieve the YouTube videos for each one with recipes for each one of them.
This is the first screen the user sees after opening the mobile application. An existing user can either log in or a new user can create a new account. I'll be creating a new account by clicking on sign up. Now, a user has to enter their existing email ID. So let's just put test3@test.com and the password as 123456. And now the account is getting created. So initially, since there's no data related to the user, the application will ask the user to enter their user preferences. So I'll select non-vegetarian. And generally, many people do not prefer having beef, so they can select that. Or if anyone is allergic to any of the ingredients mentioned in this list, they can select that. And our recipe recommendation will automatically remove it. Now, the user has to input their data, which this data consists of their age, nutrition data, etc. And after the data has been submitted to our backend, the user automatically gets a list of recipes, which they can just scroll and see. And as you can see over here, each recipe is provided with a few quick stats. So at a glance, the user can see the quick stats of the nutrition like calories, fat, carbohydrates content, and protein content. Now let me just click on this, and automatically this opens up a video scraped from YouTube. And I'll just pause it now. Here the user can get a short summary of what the food product is, and can also view the list of ingredients which are used to make the food product. And at the bottom of this page, we get a detailed description of what are all the nutritional values of this food product. So the user can get an in-depth view of each nutritional value which is related to this food product. So there'll be times where users will want to see recipes specific to a particular macronutrient, so they can just go to the recipes tab, and here, as you can scroll down, you get to see different recipes for specific macronutrients like fats, calories, carbohydrates, and proteins, and the user can just scroll here horizontally to view more recipes for a given macronutrient. And a user can repeatedly update their data using this option, and they can sign out from the mobile application from the profile screen. That's the demo of the application. Thank you.